We are back with the new video, clustering. In the previous video, we looked at data processing. In this video, we will apply clustering to the newsgroup dataset and display a scatter plot of the actual labels and cluster labels. Clustering divides a dataset into clusters. This is an unsupervised learning task since we typically don't have any labels. In the most realistic cases, the complexity is so high that we are not able to find the best division in clusters. However, we can usually find a decent approximation. The clustering analysis task requires a distance function, which indicates how close items are to each other. A common distance is Euclidean distance, which is the distance as the bird flies. Another common distance is taxicab distance, which measures distance in city blocks. Clustering was first used in the 1930s by social science researchers without modern computers. Clustering can be hard or soft. In hard clustering, an item belongs to only one cluster, while in soft clustering, an item can belong to multiple clusters with varying probabilities. In this course, I've used only the hard clustering method. We can also have items that do not belong to any cluster. These items are considered outliers or anomalies or just noise. A cluster can also be part of another cluster, which can also be an item in another higher level cluster. If we have a cluster hierarchy, we speak of a hierarchical clustering. There are more than 100 clustering algorithms. The most widely used of those is the k-means algorithm. K-means clustering assigns data points to k clusters. The problem of clustering is not solvable directly, but we can apply heuristics, which achieve an acceptable result. The k-means algorithm attempts to find the best clusters for a dataset, given a number of clusters. We are supposed to either know this number or find it through trial and error. I evaluate the clusters through the within-set sum of squared error, that is, WSSSE method, also known as the within-cluster sum of squares, or WCSS. This metric calculates the sum of the squared error of the distance between each point and the centroid of its assigned cluster. The algorithm for k-means iterates between two steps, not including the initialization of the k-centroids. We assign each data point a cluster with the lowest distance, and we recalculate the center of the cluster as the mean of the cluster point's coordinates. The algorithm stops when the cluster assignments become stable. We will use the scikit-learn's k-means class, as described in this table. The average complexity is given by big O of knt, where k is the number of clusters, n is the number of samples, and t is the number of iterations. Now this code applies clustering and displays a scatter plot of the actual labels and the cluster labels. We are reusing the same which we used previously. So we have used the k-means clustering and plotted the result. Now move on to the command prompt and type python space the file name .py. The generation of result may take some time. And here we have the cluster result. You can see the cluster and newsgroup plotted on the y and x axis respectively. In this video, we learned about clustering, its approaches and implementation in Python. Our next video will be on topic modeling.